All right, let's get started on 7.1. So I actually broke 7.1 into three sections. Um, 7.1 is got a lot going on, and we want to make sure, again, like chapter 6, that we're reading very carefully. And so this way you'll have smaller snippets of information. We're going to look at what's called hypothesis testing. There's just a little math humor there. Statistics to test hypothesis and your patients. So hypothesis testing is very important. It's where we test a claim about something. So in medicine or psychology or business, we will have a claim either from a manufacturer, from a doctor. Look at all these things with COVID-19 right now. There's different claims of what might work as a cure. So hypothesis testing lets us see if that claim is valid or not, based on a lot of information. If you go on and get your graduate degree, you're probably going to be doing some statistics no matter what field you go in. And the toughest thing is if you're making the claim, everyone's going to try to disprove you. And so you have to make sure you have your ducks in a row. So an example is a manufacturer that advertises its new hybrid car and says it has a mean gas mileage of 50 miles per gallon. But we suspect that that's not true. And so we are going to try to show that that advertisement is false. This happened to Chevrolet. They were doing a lot of advertising in the movie theaters, and some of what they were saying was not quite right. So we apparently there somebody figured out that it wasn't right, and you see that advertising is very different now. And so the biggest problem, we've talked about this the whole semester, is that we can't test every single car. We cannot test the population. And so we've got to look at a random sample and based on that sample, see if we can make a reasonable decision about the mean. Okay, so we're going to just do a quick overview here. We'll get into the guts of this as we go along. But let's say we're saying, okay, the mean is 50 miles per gallon, and we're going to look at 30 cars. Okay, so the claim is that the population mean is 50 miles per gallon. We're going to look at a sample size of 30. And when we look at those 30 cars, we find out that the sample mean across those 30 cars is 47 miles per gallon. And we have a sample standard deviation of 5.5 miles per gallon. Okay, this is information we know how to do, right? Just looking at that, does that tell us whether the manufacturer's claim is false? Well, we don't know. We're going to assume that the advertisement is true. We're going to assume that the mean is 50, and then we're going to take a look at what's going on using our central limit theorem. So again, we're going to go ahead and take our sample mean. We're going to adjust our standard deviation here. And again, we're going to do the guts of this along. I'm just trying to show you an overview real quick. So if we go ahead and take a look at our, we're going to assume this is normal. We're good. We have a sample size of 30. So our mean is in the middle. We know this. Our mean is in the middle. That's 50. We're going to jump by we're actually jumping by ones because that's our adjusted standard deviation. And so each tick mark here is another standard deviation. Well, when we did our mean, we were way down here at 47. And so the problem is, look at where we are. We are 3 standard deviations below the mean. That's a problem, right? That makes that very unusual. And so most likely, this advertisement is probably false because that didn't look so good. Now we can look at more samples. There's other things we do in statistics, but just looking at that sample versus the claim, we're going to say that the advertisement is probably false because it's too far away. It's 3 standard deviations away. All right, let's go ahead and look at a little bit of vocabulary here. We call this a hypothesis, and you've probably heard that word before. And we have what we call a null hypothesis, and then we have an alternative hypothesis. For what we're doing, we're going to always have this. So we'll have a null hypothesis and an alternative hypothesis. And the way we know which is the null hypothesis will always have the less than or equal to, or greater than or equal to. And I'm going to show you all this as we go along. This is always hard with the vocabulary that we get going first. So like that example we just looked at, that was the hypothesis was that the mean was equal to 50. Well, since it's the equal sign, we're going to say that that's the null hypothesis because of the equal sign. The alternative hypothesis is going to work off the alternative of these signs. And so it's going to be greater than, because greater than is the complement of less than or equal to. It's going to be not equal to, that's the complement of equal to. And finally, it's going to be less than, because less than is the complement of the greater than. All right, so let's look at that again. If I have a less than or equal to sign for my, what we call a null hypothesis. So this is an H with a little O right there. That's our null hypothesis. If that is less than or equal to, then our alternative hypothesis is going to be the complement, which is greater than. Okay, if our null is equal to, then our alternative is going to be the complement, which is not equal to, because there's only those two choices. It's either equal to or not equal to. And then finally, if the null is greater than or equal to, then our alternative is going to be less than, right? Because it can either be greater than or equal to, or it can be less than, right? You can't have the equal to on both of those. Okay, so some people, when we see that symbol for the null hypothesis, we just say null hypothesis. Some people say H sub 0, some say H naught. You'll hear it different ways, but we'll probably just say null hypothesis. And then the H with the A is really H sub A, but we're going to call it the alternative hypothesis. Okay, so this is written out a little fancier than what I did on the last one. So this first one, if we have a null hypothesis of that the mean is less than or equal to K, then the alternative has to be that the mean is greater than K. Okay, those two go together, they're complements. If I have the one in the middle, where the null hypothesis is greater than or equal to K, then that tells me that the alternative is going to be that the mean is less than or equal to K. And then finally here, if the population mean is equal to K, that's the null hypothesis, then the alternative would be the complement. That would be that the population mean is not equal to K. Okay, so each of those go together, and they can only look like that. There's nothing else we can do. The null hypothesis always has the equal to with it. It either has less than or equal to, it has greater than or equal to, or it literally has the equal to, okay, for the null. And then what gets interesting is the claim can be either one, and we'll deal with that as we go along. So these are the same setups. The null, the alternative, but we just wanted to show you some of the wording. We're used to this wording. We've been doing it all semester. Sometimes you'll say greater than or equal to, sometimes at least. Remember, sometimes, like down here, at most, that's the one that drives me crazy. At most, K means less than or equal to K. Sometimes you'll see equal to, exactly. So this is just some different wording. But we've been practicing these all semester on purpose so that we know how to find these inequalities, and we know how to translate from words back into the inequalities. All right, so let's set up one of these. It says, write each claim as a mathematical statement, state the null and alternative hypothesis, and identify which represents the claim. Okay, so we know we're going to have a null hypothesis, and we know we're going to have an alternative hypothesis, and we tend to put a colon right after that. All right, so let's read what it says. It says, a school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Now, this one's worded really strangely. Even though it says at least one extracurricular activity, it says the proportion is 0.61, right? 61%. And so we're going to use an equal sign, right? So the school says that P is equal to 0.61. So let's go ahead and put that into our hypothesis. And so we have to pick. It either belongs in the null or it belongs in the alternative. And since it's an equal sign, we are going to put it in the null. Always, always, the equal sign or the less than or equal to or the greater than or equal to is going to go into the null hypothesis, the first hypothesis. For the alternative, we need the opposite. Well, the opposite of equal is not equal to. So we're going to put not equal to here. All right, then they say, okay, which one is the claim? Well, the claim is what the school said. So since the school said that P is equal to 61%, that means that our null hypothesis, the first one, is going to be the claim. All right, so let's look at what this looks like with a number line. They're saying period, 61%, right? They're not saying less than 61%. They're not saying greater than 61%. They are saying that their percentage or their proportion, of students who are involved in at least one extracurricular activity is 61%. So that's the only value we're looking at for the claim. Therefore, for the alternative, it could be down on this end, on the less than 61%, or it could be greater than 61%. All right, let's try another one.